Hello, welcome to our Prep Pro HVAC MCQ question solutions, set 1 of 20 questions. The first question is, the layer of the stratosphere that protects the Earth from excessive ultraviolet radiation is comprised of dash. Let's go to the options. We have 4 options here. First being nitrogen, then chlorine monoxide, then ozone, and then oxygen. As we all know, the ozone is responsible for protection of Earth from the excessive ultraviolet radiation. That should be the correct answer. Let's look out for the correct answer, which is ozone. And the explanation says, the stratosphere is the Earth's security blanket. It is located between 10 and 30 miles above sea level and is comprised of, among other things, ozone. Ozone protects us from harmful ultraviolet radiation and helps maintain a stable Earth. Now we'll move forward to the next question. Question number 2. The molecule found in CFCs and HCFCs that depletes ozone is. The options given are fluorine, hydrogen, carbon, and chlorine. The chlorine is the molecule that is present both in CFCs and HCFCs. Hydrogen is not an option because it's not present in CFCs. But we'll talk about the only thing that depletes the ozone, which is chlorine. So chlorine should be the correct answer. Yes, the chlorine is the correct answer. And let's look out for the explanation. Chlorine is the element that depletes the ozone by attaching to one atom of oxygen from ozone. Page number 1, EPA Prep Manual. Now we'll go forward to the question number 3. What have crop loss, eye diseases, and skin cancer been attributed to? The options are depletion of stratospheric nitrogen, depletion of stratospheric chlorine monoxide, depletion of stratospheric ozone, and the depletion of stratospheric oxygen. So which is the correct answer? It should be the depletion of stratospheric ozone. Yes, that is the correct answer. And going forward to the explanation, depletion of stratosphere ozone will cause crop loss, increase eye diseases, skin cancer, reduce marine life, and cause deforestation. Page number 1, EPA Prep Manual. Now we'll move forward to question number 4. How many chlorine atoms does it take to destroy 1 million ozone molecules? Let's look out for the options given. Option 1, 1, option 2, 10, option 3, 100, and option 4, 1000. As we know that one molecule of chlorine can destroy 100,000 ozone molecules, so it will take 10 chlorine atoms to destroy 1 million ozone molecules. So 10 should be the correct answer. Yes, 10 is the correct answer. And the explanation, one atom of chlorine will destroy 100,000 molecules of ozone. So if you multiply it with 10, you'll get 1 million ozone molecules, as per the page number 1 EPA Prep Manual. So now we are moving forward to the question number 5. The chlorine in CFCs will dash. The options are dissolve in water, not dissolve in water, rain out of the atmosphere, is heavier than air and cannot rise to the atmosphere. So which should be the correct answer? It doesn't dissolve in water. So option number 2 would be the correct answer. Yes, it does not dissolve in water. So the chlorine in CFCs will not dissolve in water, And let's read out the explanation. Chlorine compounds will not dissolve in water or rain out of the atmosphere. Page number 1, EPA prep manual. Let's go forward to question number 6. What do HCFCs contain? So the options are chlorine, fluorine and carbon, hydrogen, chlorine, fluorine and carbon, hydrogen, fluorine and carbon, hydrogen, fluorine and olefin. So the correct answer should be hydrogen, chlorine, fluorine and carbon. Let's go to the explanation. HCFC compounds contain hydrogen, chlorine, fluorine and carbon. Page number 1, EPA prep manual. Let's go to question number 7. Which of the following has the highest ozone depletion potential? These are the 4 options given: HFO, HCFC, HFC and CFC. The correct answer is CFC. The chlorofluorocarbon has the highest potential to deplete the ozone layer. The explanation: based on the EPA, CFCs have the highest ozone depletion potential to destroy the ozone. Page number 1, EPA prep manual. Now we'll be going forward to the question number 8. Technicians have been required to be certified to service, maintain or dispose of appliances containing regulated refrigerants since. So what is the date? The dates given are 1st of July 1992, 1st of May 1993, 14th November 1994 and 15th November 1995. The correct answer being 14th November 1994. It is a violation of EPA section 608 to service, maintain or dispose of appliances designed to contain refrigerants without being appropriately certified as of November 14, 1994. It is the responsibility of the final person in the disposal chain. Let's go to the next question, question number 9. It has been a violation of EPA section 608 regulations to vent CFCs and HCFCs since. Let's look out for the dates given as options. 1st of July 1992, 1st of May 1993, 14th November 1994 and 15th November 1995. The correct answer is 1st of July 1992. The explanation: it is a violation of section 608 of the Federal Clean Air Act to vent CFCs and HCFCs since July 1, 1992. Page number 2, EPA prep manual. Now we will go forward to the question number 10. As of what date has it been a violation of EPA section 608 regulations to vent HFCs? So HFCs are a violation since which date? That is the question. The options are 1st of July 1992, 1st of May 1993, 14th November 1994 and 15th November 1995. The correct answer is 15th November 1995. So let's look out the explanation. It has been a violation of section 608 of the Federal Clean Air Act to vent CFCs and HCFCs since July 1st, 1992, which is one key date to remember. And the next date is it has been a violation of section 608 to vent HFCs since November 15, 1995. Page number 2, EPA prep manual. Let's go forward to the next question, question number 11. The proper disposal method of dash is to recover any remaining refrigerant, then render the cylinder useless, and then recycle the metal. That is the process. What are the options? Recovery cylinders, 1 pound cans, disposable cylinders, and accumulator cylinders. So this is applied for disposable cylinders. As the explanation says, it is a violation of Section 608 of the Federal Clean Air Act to dispose of a disposable cylinder without first recovering any remaining refrigerant, rendering the cylinder useless, and recycling the metal. Page number 2, EPA Prep Manual. Now we'll go forward to question number 12, which says, which international agreement or treaty regulated the production and use of CFCs, HCFCs, halogens, methyl chloroform, and carbon tetrachloride? So let's look out for the options. Kyoto Treaty, Montreal Protocol, Council of Nicaea, Treaty of Ghent. The correct option should be Montreal Protocol, which has been in effect to regulate the production and use of these items. And the explanation is, following several years of negotiations, an international agreement or treaty regulating the production and use of CFCs, HCFCs, halogens, methyl chloroform, and carbon tetrachloride entered into force in mid-1989, known as the Montreal Protocol. This landmark agreement initially required a production and consumption freeze. Page number 2, EPA Prep Manual. Let's go to the next question, question number 13. Which term applies to the process where clean refrigerant results from separating the oil from the refrigerant and removing moisture from the refrigerant by passing it through one or more filtered dryers? The options are recover, reclaim, reuse, recycle. The question is a definition, and what it defines is the actual question. So the process given in the question is recycle, and the explanation is, under the EPA's Clean Act, the term recycle means to clean refrigerant for reuse by separating the oil from the refrigerant and removing moisture from the refrigerant by passing it through one or more filter dryers. Page number 2, EPA Prep Manual. Let's go forward to the next question, that is question number 14. To process refrigerant to a level equal to new virgin product specifications as determined by chemical analysis defines which of the following terms, right? Okay, the options are recovery, reclaiming, reuse, and recycle. The current answer should be reclaiming. Yes, it is. And the explanation given is, under the EPA's Clean Act, the term reclaim means to process refrigerant to a level equal to new virgin product specifications as determined by chemical analysis. Reclaimed refrigerant must meet the standards set forth in ARI 700 before it can be resold. Page number 2, EPA Prep Manual. Now going forward to the next question, question number 15, HFCs. The options are will not damage stratospheric ozone, will damage stratospheric ozone, will deplete stratospheric ozone, and are only harmful to ground level ozone. And the correct answer should be will not damage stratospheric ozone. The explanation is HFCs R134A do not contain chlorine and have no ozone depletion potential. Page number 1, EPA Prep Manual. Now we'll move forward to the next question, question number 16. What is indicated when chlorine monoxide is found in the stratosphere? So if the chlorine monoxide is present, it means what? We are well protected from harmful UV radiation. Additional ozone is being created. Harmful nitrous oxide is also present. The ozone layer is being depleted. The ozone layer is being depleted is the correct answer, as the presence of chlorine monoxide indicates that the chlorine is getting an oxygen out from the ozone and creating oxygen. So that is the correct answer. The ozone layer is being depleted. Okay, let's go to the explanation. When a chlorine atom meets with an ozone molecule, it takes one oxygen atom from the ozone. This forms a compound called chlorine monoxide and leaves an oxygen molecule. Page number 1, EPA Prep Manual. So let's go to the next question. Question number 17. Chlorofluorocarbons, CFCs, have and hydrochlorofluorocarbons, HCFCs, dash. Okay, the options are both contain hydrogen, are explosive, are ODP substances, will be completely phased out in 2030. These two CFCs and HCFCs are ODP substance, which means ozone depletion potential. Okay, yes, are ODP substances, and the explanation is ODP, ozone depletion potential, is a measurement of the ability to destroy ozone by CFCs R15, R12 and R500, and HCFCs R22 and R123. CFCs have the highest ODP. HFCs R134A do not contain chlorine and have no ozone depletion potential. So HFCs are non-ODP, where CFCs and HCFCs are ODP substances. Page number 1, EPA Prep Manual. Now we'll go forward to the next question, question number 18. What are the two types of refrigerant recovery system? The refrigerant recovery system: system dependent and passive, system dependent and self-contained, self-contained and active, recycling and reclaiming. So the correct option is system dependent and self-contained. These are the two types of refrigerant recovery system. The explanation: refrigerant recovery and or recycling equipment manufactured after November 15, 1993 must be certified and labeled by an EPA approved equipment testing organization to meet EPA standards. There are two basic types of recovery devices. Number 1, system dependent, which captures refrigerant with the assistance of components in the appliances from which refrigerant is being recovered. Number 2, self-contained, which has its own means to draw the refrigerant out of the appliance. Page number 2, EPA Prep Manual. Now let's go to the next question, question number 19. When a system is in full vacuum, dash. If the system in full vacuum, which of the following option is correct? It is dangerous to charge the system. Never use a micron gauze. Never energize the compressor. No precautions are required. So the correct answer is never energize the compressor. because it could be dangerous. The explanation says a hermetic compressor motor winding could be damaged if energized when under a deep vacuum. Page number 10, EPS prep manual. So that brings us to the last question of this set. Question number 20, the evaporator dash. So the options are: changes a high pressure vapor to a high pressure liquid, changes a low pressure vapor to a low pressure liquid, changes a high pressure liquid to a low pressure liquid, changes a low pressure liquid to a low pressure vapor. What is the correct answer? Correct answer is changes a low pressure liquid to a low pressure vapor. And the explanation is heat is absorbed in the evaporator and causes the refrigerant to boil from liquid to vapor, both under low pressure. So that is the correct answer. Changes a low pressure liquid to a low pressure vapor. Page number 2, EPS prep manual. So that brings us to the end of this question set, and we are looking forward to have you to the next set of questions. Thank you very much for being with Prep Pro.